Hello all and welcome once again to the workshop. Recently broke the 2,000 barrier on my subscribers, so thank you very much for all the interest, and yeah, having got the 2,000 I suddenly got another little boost. Anyway, I'm standing next to my Long Chang First Taiwanese Bridgeport copy. Because I'm looking at a job I've been putting off for years probably, which is fitting a power feed to the knee. Now, I fitted a power feed to the X-axis a good number of years ago, and I got the drive very cheaply from the clearance table at Kronos Tools. They're local to me and I can in fact drop into them on the way to work. They had a customer return power feed and it said on the box, works in one direction only. Well, the important there to me was works. And I thought, even if it's a faulty electrics and or even a completely blown driver board, I can come up with a replacement and get that fixed. And it actually turned out to be a really trivial mechanical fault, where a roll pin on the back of the operating lever is meant to sit in a slot in a piece of plastic, which then operates the forward and reverse micro switches, and the roll pin was not in the slot. So once I took it apart, I could see that all I had to do was put it back together again with the roll pin in the right place and straighten a bit of plastic that had got bent by being incorrectly assembled. It was a Y-axis kit, but with a few modifications. I fitted on the X-axis and it's been brilliant ever since. Now, on a subsequent visit to Kronos, I found another one, and I paid 50 quid for one and I paid 100 quid for the other. I don't remember which way round it actually was, but this one was also a customer return and was apparently completely dead. And I bought it and it sat in the box, and I really don't remember how long ago it was, but sometime last year I actually dug it out, examined it to discover that the reason it didn't work is because someone had plugged it into 240 volt and they are 110 volt units. Though you can now get native 240 volt power feeds. 110, obviously, common voltage in America, common safer control voltage in the UK, though modern control voltage is usually down to around 24 or sometimes 48 volt. But it hadn't actually received all that much damage. One of the overvoltage suppressors on the circuit board had let its magic smoke out, but it didn't appear that anything else on the circuit board had actually been damaged. What had taken the brunt was the circuit breaker, which had more or less exploded. The casing was slightly popped open, and looking inside, it was plated with vaporized copper. So anyway, I took a while to source the MOV, the metal oxide varistor voltage suppressor, in the right rating and size without paying a silly amount of money for a trivial item. I ended up buying 10 from China for about £2.50, and I run it up on a high voltage power supply and it's doing what it's supposed to do. So basically the unit, it should now be fixed. But this unit was actually an X-axis kit, and I want to fit it on the Z-axis. So I needed to look at how that was going to fit. So I'll move the camera and I'll show you how the Z-axis handle and everything all comes apart, and what the changes we need to make are. Okay, let's see how we get on here. Of course, we've got the standard crank handle. I'll just drop that on the floor. I should say I've taken this all apart before, so it'll come apart really easily. On my mill, the drive dog for the handle has always been a slip fit. I believe on some of the machines that you might just need to get some pry bars in here to get it moving, and possibly even use a bearing puller, but that just slips off. You've obviously got the locking screw for the dial, then the dial itself, and in my case I've got a shim washer behind it, and that sits on this assembly, which is actually a nut, and this, which I've loosened previously, it's got a hole for a pin spanner that screws on to the shaft. There's a key, which in my case is a pillow style key. They're often a wood rough, and then there's the bearing retainer. So the bearing retainer is pressing against the outer race of the bearing, and then the nut that holds the dial is pressing against the inner race of the bearing. And this thread on my mill, by the way, is 3/4 by 16, which is a UNF thread. I believe sometimes they are an 18. I've seen references to that. The Taiwanese stuff tends to, certainly from the 80s, tends to be all in imperial measurements as per the originals. I think some of the other stuff they certainly started converting hardware, like the screws that would have held the bearing retaining plate in place. They started changing these to metric, so do check if you're tearing into one of these and don't make assumptions. Now, the way that Align or Vertex fit these is, first of all, to have a new retaining plate a little bit deeper, which is drilled for some mounting holes for the main body. You can see they've got lots of hole options in there. And then they have an adapter shaft that screws on at this end. Is a good tight fit over the shaft and extends out further for the handle. Now, in here we have a needle roller bearing, which is 24mm ID, and this kit came with an inner bushing, which takes it down from 24 to 20. So, as I say, this was the X-axis feed, and the adapter kit would have had a 20mm diameter for the race to sit on. What they do on this kit is the extension shaft has a 24mm OD section where the needle roller runs directly on it, and the instructions for these things, there are some good ones around. The ones that I had were fairly indistinct. You know, they were fairly small drawings, and it was a little bit difficult to see what was going on. Did find one fairly good video on YouTube, and I did some CAD work and I drew up the various bits, because one of the things you've got to do is you've got your bronze bevel gear, and you've got its pinion in here, and you need to shim the clearance to get the engagement right. You don't want it too tight and binding. You don't want loads of lash in it because it'll wear. So this gear then needs to be held onto the shaft so that you set the clearance. So the Align setup involved having a nut with the drive dog for the handle that was actually threaded M20 and screwed onto the end of the extension shaft to compress the gear and shim and bearing stack up, and then the shaft would extend further out and would engage with the crank handle, and then their idea was to put a spring in so that the handle would automatically disengage and be retained by a screw on the end. And this is so that the power feed was not, if you couldn't forget to disengage the handle, and if you powered it up, it wasn't going to spin the handle around and give you a good crack somewhere unfortunate. Now, one of the things I do, which I think most Bridgeport style mill owners will do, is to reverse the handle, store it there and avoid having the handle sticking out to catch your knee. And obviously you can't do that if there's a screw on the end. So I was just having a look around, seeing what the solutions were, thinking about getting a round hand wheel which I could leave permanently engaged, there not being nothing to catch, but I could still operate manually satisfactorily. And that actually took me to a page for installing an original servo power feed, which is the design that's been copied. And they do the setup somewhat differently, and in fact somewhat more simply, and should result in me doing quite a bit less work. This is a 5/8 inch shaft, and that's how the bronze gears come, set up for X and Y. And if I put the key in here, keyway's right, and that's would all work fine. And the servo kits have you pull this shaft out of the mill knee and fit an extension on here. I can't remember if yeah, I think the idea is it screws, you drill and tap, screw in the extension shaft and pin it, and I've forgotten the exact arrangement, but they're often using a circular wheel on there with a spacer. Yeah, that's right. But I've decided to basically copy that idea and to use this. I think what I'm going to do is, because I seem to recall that I can't get this shaft out on this machine because the inner bearing is retained and requires you to gain access. So my idea is to make up a guide bushing which will allow me to drill and tap the end of the shaft in situ, and I'm probably going to attach my hand wheel onto this extension of the bronze gear, so that I won't even need to extend this shaft at all. I obviously need another nut, and that needs to incorporate either a 20mm, sorry, that's was it 24mm OD for the needle roll to roll directly, or if there's room, and I think there is, just about, be relatively thin walled, but should be fine. Whatever I end up doing, one of the parts that would remain the same is the new bearing retainer plate. This one sits recessed, and it needs to sit slightly proud, and it needs to have 2 holes drilled to mount the main body. And this is a piece of cast aluminium. I can see a little bit of porosity in it, so and it's not got a huge amount of depth even when it's thicker. So I'm going to make another one in steel, which will be a little bit stronger to bolt into, and that will remain the same whichever conversion done. So the CAD work I've already done has enabled me to produce a drawing. So my first job will be to get that machined up and mounted, and it's all very straightforward machining, so I may not do any footage of that, and we'll just come back later when that's done and ready to be mounted. Okay, you can see we've made a little bit of progress here. I started off by making the new bearing retainer, which is a few millimetres thicker than the original, and this is in steel rather than aluminium, so it's going to take the threads for actually attaching the body of the power feed rather better. And I've made a new nut, so this is a reamed fit onto the shaft. It's got the 3/4 inch UNF thread in, and I've machined it to take the bearing in a race for the needle roller in the feed, and I machined this to a transition fit. So with the relatively low temperatures out in the workshop and actually just putting that in my pocket for 20 minutes, I could then squeeze it on pretty easily, so I'm quite happy with that. But it then became fairly obvious that I probably shouldn't try and get away with drilling the end of the shaft and tapping it to retain everything. And if I just stack things up, I'll show you why. You can see the keyway there. Let's see if I can get you in tighter. Oops. Okay, yeah, that's better. You can see the keyway there actually gets partially covered, and I'm going to lose a fair chunk of that. And this is how I think the servo one fits, the genuine servo units, looking at their diagram. But it meant that this key is, well, in the sort of diagrams and everything, it indicates that it's an 1/8 inch keyway. And I was measuring it and it's not coming out right. And this is in fact more like a 2.9 millimeter key. And the keyway is not quite 3 millimeter. And surprisingly, the keyway in the gear is 3 millimeter, and I know because I actually bought a broach set, and the 3 millimeter broach is spot on in there. Well, that's fine. I've got no problem with that. But I want to extend this this keyway, and I'm going to extend this shaft out to a decent length so I can fit the hand wheel. And let's come right the way out. And I found myself quite a nice hand wheel actually. It's cast iron and chromed, and it was £10.99 delivered, AIM tools on eBay. And I thought £10.99, you know, it'll do. And I'm pleasantly surprised. The finish feels smoother than it looks on the inside. They've done a reasonable job on the outside, turning it down. I'm going to be quite happy with that as a hand wheel. I probably won't fit the swivelling handle, because then that's sticking out with the power feed, and the whole idea was to have a smooth rim that I could you know, do manual Z feeds when not actually using the power feed itself. So I need to get this shaft in the lathe in order to spigot this and I may well TIG weld an extension on and then turn it back to match. It's probably the most accurate way. I'll have to check the concentricity between the main body of the shaft and the journals, and if necessary put the forge jaw on. It would be nice if I could just do it in the collet chuck. There'd be a lot less work. But I can't get anything into the lathe until I've removed the gear and the bearing. And I mentioned before that I thought that the inner bearing was fixed. Well, it wasn't, but it was a relatively tight fit, and from what I've read about genuine Bridgeports, this bearing is generally a slip fit, and it's the outer bearing that's a tighter fit, and this one seemed to be the reverse. Anyway, a little bit of leverage, and that came out okay.